Now let's look at this example. What you could do is you could pause the video and read the question once. It is all about Go Backend, and I also expect that you have already seen the videos of Go Backend. And now if you do one thing, you please pause it and make a copy of it so that I'll read it out, explain you, and I erase it, and on top of it I'll solve the question. So look at this. Consider the Go Backend protocol with a sender window size of n, which means it is Go Backend is used and the sender window size is n. What about the receiver window size in Go Backend? It is always 1, isn't it? And suppose that at time t, which means at some point of time, the next in order packet the receiver is expecting has a sequence number k, which means always the receiver will expect in order packets only, and they are saying that the next packet which is expected by the receiver is having the sequence number k. What does that mean? It would have already received all the packets from 0 to k minus 1, that is why the next packet is expecting is k. Assume that the medium does not reorder the messages, which means all the messages are going in order. Then what are the possible sets of sequence numbers inside the sender window size, which means they are asking about the status of sender window size at time t. What is at time t? Receiver is expecting the next packet as k. Assume that sender already received acknowledgements, which means whatever packets it has sent, it has already received all the acknowledgements. Then if the receiver is expecting the next packet as k, then what are the outstanding packets at the sender side? Okay, so I'm going to erase this and I'll just solve the question here. So they are saying that at time t, at some point of time, they are saying that receiver is waiting for the receiver is expecting for k, which means receiver has received 0, 1, 2, 3, so on, k minus 1. All these packets have already been received, and receiver has already sent all the acknowledgements and the sender has received the acknowledgements. Then what is the status of the packets at the sender side? That is what they are asking. So if the sender has already received 0 to k minus 1, all these packets will not be in the window. Then what will be the packets in the window? The next expected packets, right? So what is the packet next expected by this? K, and then k plus 1, and then so on. What is the last packet? The last packet depends on the size of the sender window, and is already given that the size of the sender window is n. Therefore from k to k plus n minus 1. So from k to k plus n minus 1 is nothing but all the n packets. So if the receiver the sender has already sent all the received all the acknowledgements from 0 to k minus 1, it will be having the packets from k to so on, so that the total number of packets are n. So how many packets will be there? K, k plus 1, k plus 2, so on, k plus n minus 1. Why k plus n minus 1? You just count this, the number of packets will be n. So how to count the packets? Take the last sequence number, take the first sequence number, subtract it and add 1. Then you will find out. So last sequence number is k plus n minus 1 minus first sequence number is k, subtract it and you add 1, then you can find out how many packets are totally in the window. So how many packets? If you do this, you will get it as n. Therefore all the n packets which will be outstanding will be from k to k plus n minus 1. Now let's see the second. Therefore the answer is k to k plus n minus 1 for the first question, for the linked question, first one. And for the second question, for the same information, they are saying that if acknowledgements are still on their way to sender, which means receiver has received the packets but the acknowledgements are still coming back, then what are all the possible values of acknowledgements in the messages currently propagating back, which means from the messages coming back, what will be the acknowledgements present. So we are assuming that all the packets that the receiver has received, let us say the receiver, all the packets that the receiver has received will be from 0, 1, so on, k minus 1 is the last packet received, right? Then what is the next packet before that received? K minus 2 is the packet received before it. Before that k minus 3, so on, right? Therefore all the acknowledgements will be sent for all of them. Assume that in worst case acknowledgements are sent for every packet. It need not be the case, but then I am assuming that in worst case for every packet one acknowledgement is sent. It doesn't hurt. I mean, it is not wrong. The reason is in Go Backend cumulative is obviously used, but then it doesn't rule out the possibility of independent. So I'm just assuming that all for every packet, independent acknowledgements are being sent. It doesn't hurt. So now what are all the acknowledgements? What will be the acknowledgement for this packet? I told you that it is +1 always. If you receive the packet number k-1, then the acknowledgement will be k. What about this? If you receive the packet number k-2, acknowledgement will be k-1. What about this? Acknowledgement will be k-2, so on. What is the last packet? If you start from here, then how many packets could be outstanding at any time? Maximum number of outstanding packets should be n. Why? Because at the sender window side, since the window is n, the number of packets that can be outstanding is n. Therefore, how many acknowledgements will you be expecting at any point of time? Only n in the worst case. And what those n? The last one that is being sent from there, you have to expect the n. So the maximum number of outstanding packets there could be n. So if you have already received k-1, then what is the nth packet from k-1? K-n. Therefore, this is the last outstanding packet that will be there in the sender side. So what will be the acknowledgement number for that? k-n+1. Therefore, answer for this one is from k down to k-n+1. These are the acknowledgements which will be on their way in the worst case. And how many will be there? We don't know. That depends on either they are using independent or cumulative. But then anyway, there will be these numbers on one of them, or there will be this set of numbers on how many ever number. That depends on the cumulativeness. How many, for how many packets they are sending these acknowledgements. So just see this. Is there any option there? K2 k-n+1. So there is no option. I think the closest option is this one, C. Actually this has to be k-n+1, but then it is not given, but the closest option is C. How did I get it? Again, one more time, see this. I am saying that receiver has already received till k-1, right? And then they are asking if the acknowledgements are on the way, what will be the acknowledgement numbers on those packets. So how many packets can be outstanding? N packets. From k-1, if you go down, it will be till k-n, right? So what will be the acknowledgement for each packet? You had to add +1, which means the acknowledgement for this one is k. For this one is k-1, k-2, and for this one is k-n+1. All these packets can be outstanding. Therefore, these many acknowledgements could be on the way at any time. But then I am not saying that all these n numbers will be on n packets. That depends on the cumulativeness, which means these two, instead of these two, you can have only one, or you can have only till k-1 and then k. So all the acknowledgements may not be there. The reason is go back and use this cumulative acknowledgements. But anyway, in worst case, you can expect that this is the answer, right? But the problem with this one is actually they are saying that n+1 acknowledgements are present, isn't it? From k to k-n, the number is n+1, not n. So answer is k to k-n+1, right?